Hello and welcome to Wildly Curious, a podcast that tells you everything you need to know about nature and probably more than you wanted to know. I'm Laura.
And I'm Katie, and today we're going to be talking about extreme weather and how it showcases just the craziness that happens. And I figured this is actually really timely because it's in the spring right now when we're recording this.
And we're going to start seeing some crazy weather.
I did in Texas last week.
Oh yeah, we did have some crazy wind.
Good night. Yeah, semis blown over on the highway. The carport outside of our apartment peeled the roof off of it.
Yeah, we had a lot of downed trees.
Crazy. Yeah.
And power outages.
Go ahead, I'll let you go first then.
I'm going to start with the most minor of the extreme, I guess in like my opinion, which is I'm covering 3 different phenomena. Katie's kind of hitting all the different precipitation, where
the rains.
I've got lightning and windy stuff. Okay.
Lightning and windy stuff.
So let's start with lightning. It's so freaking cool. I love a good thunderstorm with lightning.
It is good.
I like to sit out on the porch like a crazy person, not exposed, but out there, and just be surrounded by the elements like that.
Yeah. We don't have good thunderstorms, real thunder lightning storms like we did back north and
you need
back
those
in the
mountains.
Northeast.
Yeah.
Yeah, we don't have that here in Texas. So I do miss it. You hear it, but again, if it rains, it's once every 3 months because it's Texas. So then if you get rain with a good thunderstorm, that's even rarer.
You're like, whoa.
Here. Yeah.
So real quick with lightning, I don't want to get into in the weeds with how it's formed and all that kind of stuff, but leave it to say it is electricity that happens. Normally the air dampens the electric current stuff that happens, but eventually, because of particles zooming around because of storms, that insulator breaks down and then like that electric spark happens. Isn't that a good sound effect? That was the thunder part, not the lightning. Well, the first part was the lightning. So typically what we find are negatively charged strikes. So negative at the cloud, positive at the ground. Okay.
Yes.
They travel about 60,000 miles per second. So it's very fast. Yeah, very fast. And sometimes when you see that flicker, it's because, it's not necessarily just one stroke. It could be 1 to 20 strokes per flash. So it might be like rapid fire. And just typical old run-of-the-mill lightning can reach 300,000 amps and 30,000 Kelvin, which is 5 times hotter than the surface of the sun.
Again, how people even survive lightning strikes?
I don't, right? That's like wild.
I guess it's because it's so fast. It's like a flash burn.
I just can't believe, that your body doesn't have the time. You've literally touched something 5 times hotter than the sun. That you didn't instantly disintegrate. It's mind-blowing.
Yeah, no, right? That's what you would think that would happen.
Which is like,
just like, boom, ashes immediately.
Yeah, just absolutely.
And that's how internal combustion came around. You know what I mean?
The myth of people talking about somebody blinked and didn't see the flash.
Yeah, and just like ashes. All of a sudden, just boom.
And that's just regular lightning. So I wanted to talk about a few of the more extreme, so first of all, there's what we call super bolts, which is positively charged lightning. That's the opposite, positive at the top, negative at the bottom. They're more rare, but also much more powerful. They are responsible for the extreme destruction that you see with lightning storms and typically the culprit for starting wildfires because they hit with up to 300,000 kiloamps. So that's 10 times stronger amps than a regular bolt of lightning. Yeah, it's just
because it needs to be stronger. Okay, evolution, everything on our planet, be like, you know what? This is not hot enough or not.
This is not. It's not enough.
Let's make this better. I feel like I can do better. And, Mother Nature just, here we go. Yeah. Like, I can do this better.
So that's the most powerful is a super bolt. And then you have something called a mega flash, which I also just like the names of this. Super bolt, mega flash. These are super rare. And they're called this because they span huge distances and can cause multiple cloud-to-ground strikes, which is the most common, cloud-to-ground. These can span huge distances and cause multiple cloud-to-ground strikes, which are the most common, cloud-to-ground. So imagine it's this giant long flash with multiple fingers like...
Oh, yeah, I know what you're talking about.
And so when I say vast distances, I mean freaking vast. The longest one ever recorded was in your neck of the woods. It spanned 477 miles. That's how long that lightning bolt was.
Which is like a blip of Texas.
Yeah, well, it's from central Texas to Mississippi in 2020, which of course it was 2020 when we all thought the world was ending.
Yeah, why not?
You know?
Yeah.
Only satellites saw that flash that big, you know, like just I can't even imagine. That would be such a cool thing to see from space.
But also too, you got to think of the storm front. How big is that storm? You know what I mean?
Yes,
for that to happen,
to go so far and to be so charged that whole time. We were all feeling pretty charged at that time.
Yeah, right.
Just the universe.
Yeah.
Okay, now weird types of lightning. We've got ball lightning, which we've probably all heard of. But again, it's a really rare phenomenon. And seriously, nobody really knows how this happens. It's still being studied. And is it even a true form of lightning? But it's essentially a ball of light that floats or travels unpredictably through the air. It can be the size of
even better.
Right.
It's unpredictable.
Unpredictable. It can be from the size of a baseball to several feet in diameter. Jeez. And then can just randomly explode.
Good.
So it's just a lightning grenade that just...
Yeah.
My dad says he's seen one once. Totally freaked him out. Came in through a window or like something like right by a window.
Yeah.
Anyway.
Because again, I would be like, "Oh, that was a UFO. I just saw a UFO." Yeah. That would be me.
Erratically flying.
Right?
Ribbon lightning is also really cool. You'll have to look up a picture of this. I've never seen this.
Ribbon lightning?
Ribbon, yes. So it's when there's really high winds involved. So the wind shear causes the bolts to happen in parallel flashes. Each successive bolt follows a different path, which causes these wide-looking bolts. Really, a lightning bolt is only about 2 inches.
Yeah.
Normally, it's about a 2-inch wide bolt, but because of the wind, they're not following the exact same path. It's right next to each other.
Wait, what's normally a 2-inch wide bolt? Just like a normal lightning bolt?
2 inches.
That's crazy.
Yeah,
it's a lot of heat and power in that.
In one tiny little
2 inches. Oh,
listen, man.
Size doesn't matter.
Just don't call me lightning bolt. And then high altitude lightning, or high altitude phenomena almost. Okay, so this is lightning that we almost never see because this is happening actually above the thunderstorm. The 3 most common types are sprites, jets, and elves. So again, like a sprite and an elf, ethereal being. So these are like very quick.
Wait a minute.
They're called that because these are like very quick, flashy things. So
okay, because I was like, did we just jump podcast episodes?
We did. Yeah. I'm gonna add in as much fantasy here as possible. No.
All right.
Sprites are large, bright red flashes that occur way up above the cloud. I'm talking 60 miles up above the thunderstorm. Into the mesosphere. They're rarely seen with the human eye, and if so, only at night, because even though it's red, of course, we know red light doesn't travel. It just doesn't travel very far. So sprites, you can look up an image of these, listeners. If you just look up high altitude lightning, there's a really good diagram of these 3 things happening because they're happening almost at different levels. Jets are typically blue or purple streaks that flash upward really quickly, and they go about 25 to 35 miles up above the storm. So it's just like a giant finger that goes up rather than down. And finally, our elves, which we only just discovered, I think, in the 2000s. Yeah, because they're only able to be seen from way high up from space or like with cameras. They're giant round discs of light that occur due to lightning below, but they're happening at the very top of the atmosphere in the ionosphere. So like that, like magnetic field spot. They can be
that's cool looking. I'm looking at a picture right now.
Yeah, 300 miles in diameter, but they last less than 1,000th of a second. So we're never going to see it.
Yeah. I was going to say, is that even possible to see with the human eye?
I don't think so.
Because it's so fast.
So fast. Which those are directly tied to these terrestrial gamma ray flashes, which is basically just energy in the form of gamma rays being shot into space from thunderstorms. Incredibly rare, and we've only noticed it with satellites, but they can actually impact the satellites. So if a thunderstorm is happening on the ground, crap's going down, but crap's also going up. Like I was
going to say, I feel like we as humans, we hardly see any of the lightning that's actually... You know what I mean? We only see a small bit of the lightning.
Yeah, we only see cloud to ground. I mean, sometimes, so there's cloud to cloud, there's intra-cloud is within, cloud to cloud is to, there's lots of different things
Oh,
happening.
the sprites are pretty cool looking too.
Yeah, yeah. So yeah, those are, and then I would say, who gets the lightning prize for extreme phenomena and the weirdest stuff happening on Earth is happening at the Lake Maracaibo region in Venezuela. It is so crazy there. It's the lightning capital of the world because it experiences more lightning strikes than any other place on Earth.
Do they know why?
It's still being speculated. It's happening right at the mouth of this river, at the entrance of the lake. Okay,
Something cursed happened there.
There's been so much speculation. Is it because there's methane coming from the bog? Because most of this is happening over top of a bog. Does it have to do with methane?
Okay, there's your sign right there. Like,
Avoid that bog. It's clearly cursed.
somebody took a cauldron out of that bog. I'll bet my money on it. Now they gotta return it.
Yes.
Gotta return it.
Because it's been striking there, and this has been happening for 500 years at least. I mean, it's been recorded like 1499. People are talking about this.
Jeez.
So because it's been happening for so long, and it's such a weird thing, it's got its own name. It's Catatumbo lightning,
Catatumbo.
which is the name of the river. And
Yeah.
they're not sure if it's methane. They're not sure if it's because of uranium nearby. They're not sure if it's like something being charged. I've also
The
heard.
fact that they even have all these factors that they have to consider is
Don't live there.
terrifying. It's
Don't
like,
live there.
yeah, it's like it doesn't matter which one of these, uranium, like all this stuff, and it's like it doesn't matter. We shouldn't be here regardless.
Well, and so whatever it is causing 365 days a year. Half that time, practically, 140 to 160 nights per year. There's thunderstorms. So
That's
just
crazy.
most of the time. And there can be up to 280 strikes per hour. Okay.
Dang.
Just you watch the images
That's
of it. It's
insane.
bananas. That is
Yeah.
clearly, if you were a primitive people, you'd be like,
God hates this
God,
place.
something
Yeah.
is involved here because it's
Yeah. Dang.
a lot of people have died from getting struck by
So
lightning.
what's there? Is there a town there, or is it just in the middle of
There's
nowhere
like a
kind
fish.
of thing?
I've seen pictures of like villages along the sides of the lake.
Dang.
I guess you just accept the fact that at any moment you could be struck by lightning.
I wonder if the people there have crazy story. You know what I mean? Like because at that rate, everybody would have to know somebody who's
been struck
gotten.
by
You know what I
lightning.
mean?
Yeah.
Yeah.
Well, can you imagine if it was like the United States, like the insurance premiums to live
Oh
in a
my
place
gosh.
like that?
They don't even cover it. You kidding me? That
No.
would be one of those places like how Florida they don't cover flood
Yeah, they would
charges
just
and stuff like
refuse. Yeah.
Yeah, same thing there. They just wouldn't cover it.
And that is the crazy phenomena of lightning. There's many different kinds. There's some that's more powerful than others, and there's places on the planet to avoid.
Yeah, clearly. Yeah. Alrighty, well, like Laura said, I'm going to cover all sorts of precipitation in general. And so it's just rain. That's really what it is. Just different kinds of rain. So just to give you a brief overview, I know everybody knows what rain is, but do you really know what rain is? And because again, it's one of those things that's always been around. Do you really stop to ever kind of just think about it? At its core, rain is simple. It begins with water heated by the sun evaporating into the air. This vapor rises, cools, condenses into tiny droplets, forming the clouds that float above us. Over time, those droplets collide and grow larger until gravity takes over and pulls them back to Earth as rain.
There's a great Storybots episode about this. I highly
Oh,
recommend.
Storybots?
Storybots
Yeah.
is a great episode on how rain works.
There's a really good, that one is, any Storybots
They're all
episode,
funny.
honestly,
Yeah.
is really good. But here's the thing, as normal as rain can seem, sometimes rain isn't predictable or understandable, or all these different random things happen. Like, what if rain wasn't just water? And so that's what I'm going to go over, is just this 3 different types of precipitation in general that we see. So the first one I'm going to talk about is pink snow.
Ooh,
Yeah,
fancy.
right? So imagine that you're hiking somewhere, you're out and about, and then all of a sudden, in some polar region, of course, and I just say some, but I'm going to tell you where exactly you can find this. And all of a sudden, you just see, it's pink, but it's more of a reddish pink. But it also, oddly enough, smells faintly like watermelon.
That's bizarro. I
right?
mean, it would be a weird, for me, it'd be a weird, like,
Brain
split
thing.
decision, right? Where I'd
Yeah.
be like,
I
everything
eat
in you would
this?
say, absolutely don't touch that because there's something wrong with it.
But
the other part of
also-
it smells so good. It smells like a
Yeah,
snow
but
cone.
also, if it smells like watermelon, does it taste like watermelon? Yeah. So the science behind pink snow, the pink color in snow isn't a trick of the light or something, some sort of pollution like a lot of people think. And that was the first theory around it, was that it's just how light is reflecting off of it. False. Then it was, that's just how the snow, it's polluted and it's picking up also, no, false. So it's caused by microscopic algae, primarily, how do you say this?
Is it a type of red algae?
No, Trimedodomus niveus. I don't know. Anyway, it's a type of algae, and it's a very hardy little organism that thrives in some of the harshest environments on Earth and places where, honestly, most other life struggles to survive. So what happens is during the warmer months, the algae bloom produces a reddish-pink pigment called astaxanthin. So in this pigment is not only shields them from the UV damage, but also gives the snow its striking color. So you're not going to see like red snow. Yeah, like it's not going to be, a blood snow.
Yeah.
It's all of a sudden the snow is landed, then all of a sudden it's pink, and that's because it's the algae on the ground.
Okay.
Astaxanthin, or whatever it's called, might sound familiar because it's the same pigment that gives shrimp, krill, or even flamingos their pinkish and red hues.
All right. Yeah.
So where is all the pink snow found? Well, there's some of the most famous places include the Sierra Nevada mountains here in the U.S.
Okay.
Hikers and mountaineers have long reported seeing pink snow during the summer months. Greenland and Antarctica. There's a lot of research that's been done to document large patches of pink snow during the summer expeditions. Because remember, it has to be summer because of how intense the sun has to get for it to want to protect itself.
Yeah.
And so it has to be summer. So think of the places in summer where snow would be.
Still, yeah.
Yeah, so Greenland, Antarctica, and then the Italian Alps, too. So in recent years, pink snow in this region has gained attention as a sign of climate change, with scientists connecting it to increasing algal blooms because of the rising temperatures.
Right.
So we're starting to see more and more of it, because it's not a pollution, of course, because we know that it's algae, but it's also not a good thing.
Right, because they're obviously more UV is reaching Earth.
Yes, a lot
because
more.
They need to protect themselves.
Yep, and so that's what's coming of it.
So there's no way that somebody hasn't tried this pink snow.
Oh, there's no way. I didn't come across it, but there's no way that somebody hasn't eaten it.
Yeah. Because didn't we remember how you and I, when we did, I think, a podcast episode, and somebody, or it was a nature news thing, and somebody had tried the woolly rhino that they had discovered?
Ugh, yeah.
Remember? We were like
somebody
would eat like a mummified Ice Age mammal. Surely someone's eaten pink snow.
Oh, hands down. Yeah, somebody's, even if they knew it or not, they were just like, let's see what this is.
Yeah.
Some of the research is being done behind it. Again, there's a lot, because once they figured out that it's the algae, they're like, okay, we should probably study this to really see what's going on and see if it is linked to climate change and what's going on. And the studies have started to help us understand the resilience of life, and could even have implications for astrobiology. Think about how microbes might survive on icy planets or moons, if there is life, if we end up finding it on other planets. Researchers are also examining the impact of pink snow on the environment. Because the algae darkens the snow's surface, they increase its ability to absorb sunlight, speeding up melting. So yes, it's like the algae is protecting itself, but it has negative implications on the world around it. So this is particularly concerning in places like Greenland and Antarctica, where accelerated ice melt contributes to rising sea levels in a pretty alarming rate as of right now.
Yeah.
So a study conducted in 2020 in the Italian Alps linked algal blooms to changes in the microbial composition of snow, further emphasizing how these ecosystems are shifting with climate change, and rapidly, because evolution has happened over millions of years, and now these things are having to adapt and change at a much, much faster rate since humans have been around.
Yeah.
So what is
the
the pink
scheme of things?
No, right? Yeah. Oh yeah, definitely much faster. So while pink snow might be stunning to look at, it's not really just a pretty picture. Its darker hue absorbs more sunlight, like I said, than regular white snow, causing it to melt faster. And this creates a feedback loop. Faster melting exposes more sun to algal growth, which in turn accelerates melting faster. So this cycle just poses a serious threat to any glacier and polar ecosystems around the world. So pink snow might seem like a modern curiosity, but it's been observed for centuries. Aristotle himself noted its existence back in ancient Greece. Later, polar explorers reported seeing pink or red snow during their expeditions, added to the lore and mystery surrounding this phenomenon of what it was. And some cultures have even attached myths to its appearance, interpreting it as a sign of good fortune or an omen, because it used to be very rare. Not so much today, because today, while we understand the science behind it, pink snow definitely is interesting, and people definitely flock to these areas once they find out that it happens. but it's not necessarily an all around good thing right now. So the pink snow is a vivid reminder that even though some of the most extreme environments on Earth are alive and it's cool to see that life and that life can live there, it really is also a warning sign because those ecosystems are at times a lot more vulnerable than other places because there isn't a whole lot of life in these cold areas.
Yeah.
And so whenever they're being, I don't know, affected as quickly and as visibly quickly as they are, that's not really a good thing at all.
Yeah, it's just another niche ecosystem. Like anybody
Very
who
much
lives in
so.
a niche ecosystem, it doesn't do well if there's change.
Yeah, no, absolutely not. And so those, again, it's an indicator ecosystem. You know, you have indicator species, frogs and stuff that are normally the first ones to show signs of, hey, this is good or bad whenever things are changing. It's like an indicator ecosystem if there was such a thing. So that's pink snow.
All right. I'll take us in kind of the opposite direction from snow. My next weather phenomena is a haboob. Which is such a fun
Haboobs,
thing
a good
to talk
haboob,
about. Yeah.
right?
Most of us have seen a sandstorm in a movie in some way, whether it be like The Mummy Returns or The Mummy or
Yeah.
one of those. But
That was a good haboob in that
was
movie.
a good one. Well, this is the true name for such an event. Dust storm, sandstorm, haboob. Same thing.
Yep.
It comes from an Arabic word which means strong winds or blasting. And they typically occur in desert regions of Northern Africa, the Middle East, which, okay, you're expecting, and then, but also the Southwest United States. So just because it sounds like something that happens somewhere else, and that it's an Arabic word, does not mean that the phenomena doesn't also happen here.
We just had one last week.
Yeah.
A haboobs week. Straight up. Like it was, it's
Straight up.
So, yeah, we just had terrified because it was after the crazy storm and
the wind.
West Texas is so dry and it kicked up all the dust our way. You could be a few miles from the downtown and you couldn't see it at all. It was crazy. And then as fast as they came, gone.
Yeah. How do they form and what are they? You hear that word, but you're like, okay. Most of the time it starts with a thunderstorm. So it's good that I'm talking about this second. Thunderstorms, besides all the electricity that they're also causing a lot of winds. But it's not just like a blowing wind, okay? It's specifically a thunderstorm creates some really serious downdrafts because of temperature changes. And so imagine I'm dumping a bucket of water onto the sand, okay? And so that splash is going to hit and then immediately whoosh, fan out in every direction. That's called a gust front. As it smashes into the air, smashes into earth, creates this intense wind. It's hitting the ground hard, and it's going to pick up any loose dust, sand, or any other debris on the ground. This isn't as possible in wetter climates like out here in the east because
Where you guys have rain.
right,
Yeah.
because the soil is more compact. Things are held together. The more dusty and dry things are, the more likely this is to happen.
The more haboobs.
The more haboobs. The more you need these dry, loose particles for it to work. So the gust front picks up all the particles and forms a giant wall, like whoosh, a giant wall. They can be several thousand feet high and miles long. Really, these gust fronts always happen with storms. We just don't see it. They're invisible out here in the east. You still feel the wind, but you don't see it until it's picking up these particles. And these dust storms can form in as little as 30 minutes, making them really unpredictable because they just form so quickly and get so serious so quickly. It's just hard to know what to do.
Yeah, because I mean, like the one here, you could still see a couple miles. So it wasn't like someplace like Middle East and everything where you can't see your hand in front of your face kind of conditions. It wasn't like that, like a sandstorm, but it was bad enough that it definitely had an effect. But not hey, I can't drive.
Right.
At least not here. I know a little bit west of the DFW area, there were some areas like people had to pull over and stuff because it was way worse.
Yeah,
it
and you
was
don't
still
have much
bad.
warning about it.
Yeah. They were predicting that this was probably going to happen just because, again, we're like, hey, this is
thunderstorms.
We have the
and
perfect
winds
conditions.
And,
we have the perfect conditions for it. But so just FYI,
drought, thunderstorm could lead to this.
Yep.
So what's so bad about them? A few things. Strong winds. Typically, these winds are from 50 to 60, but it can also reach up to 70 miles per hour. So that's like hurricane force winds. And it's blowing over trees, and so also pushing all that dust, which causes the storm to move very quickly. Like I said, they're unpredictable and can travel for actually pretty long distances. It doesn't have to be like in and out. It can be lingering. Visibility can drop to almost zero, which can be super dangerous for anyone traveling in a vehicle or on foot. And then, of course, the dust can cause severe respiratory issues. You can't be choking on that stuff, especially in the modern world where it's not even just dust.
Haboob.
Right?
Yeah.
Yeah, it's not even just dust anymore, right? Imagine like all the heavy metal. We've just got so much crap in our soil. It's just, it's not a good thing. So what are some of the worst haboobs in history? One of the worst in modern history was in 2011 in Phoenix. It's not that rare for this to happen in Phoenix, apparently. I kept reading about different worst one, Phoenix.
Yeah.
But in 2011, this one was 100 miles wide. So
Dang,
it was just a wall, 100 miles wide, several thousand feet high, 60-mile-an-hour winds, and nobody could see anything for several hours, but it had long-term impacts for several days.
Yeah.
Just horrible.
Crazy.
And then perhaps one of the most famous, at least in the United States, where Katie and I are, it's called Black Sunday, which happened on April 14th, 1945. So this happened in Oklahoma. It formed in Oklahoma and reached to Texas, in the panhandle of Texas. And it was, again, like 60-mile-an-hour winds. There was so much debris and dust, it actually turned dark on that during the day, and people could not see their hand in front of their faces. Jeez. It was so traumatic, people actually thought it was the end of the world, filling people's lungs and houses and everything.
Yeah.
And songs are written about this, and that the next day, when this was reported on, they said the Dust Bowl. This was the start of the Dust Bowl.
Oh, interesting. Okay.
So Black Sunday was like the day that we finally named the phenomena of what was happening over there, which was this: we had totally trashed the soil from farming and taking. And it was just all dust. That was the start. And of course, also, it's right after the Great Depression. It was a bad situation. So yeah, haboobs. If you are caught in something like that, you should pull over, turn your vents off so they're not sucking in from the outside, secure your windows, things like that.
The worst one here, as far as dust wise, for us, it's definitely not classified as a haboob, but every year in Texas we get the Sahara sands that come over. Let me tell you, okay, we do get haboobs here. However, like I said, they're not horrible. They're bad enough, but they're not bad. That Sahara sand, though, causes allergies. At least my allergies. I know several people that every time, is to the point where whenever I see it in the news, I text my employees because I'm like, here come those Sahara sands, because it happens every year.
Yeah.
And it just carries so much pollen and then just dumps it in our area that we're all like, Benadryl, like more Benadryl.
Yeah.
Because it is so bad. And even whenever that last haboob hit last week, I mean, it's still, I mean, I'm not going to go for a run in it. You know what I mean? Because you can definitely tell a difference. Alrighty, haboob. I don't really have a good segue because I'm talking about blood rain next.
Well, okay, no, I got your segue. All right.
You always do have a good segue. Go ahead.
It's the ADHD. I'm like, okay, The Mummy.
Okay.
Right.
Okay.
So in The Mummy, there's the giant sandstorm bowl, and then Plagues of Egypt, blood.
Yep. Boom. Plagues of Egypt. All right. Blood rain. So rain is supposed to be clear and refreshing, right? Nope. Sometimes it's just not. So let's go ahead and talk a little bit about the science, and same kind of, I'm hitting for the most part the same different categories that I talked about. So despite its dramatic name, blood rain isn't a supernatural event. It's not blood. Its red color comes from tiny particles of sand or dust, often carried over long distances by strong winds. So very similar to Laura's haboob. These particles mix with rain clouds and tint the rain as it falls to earth, but those ancient times didn't know that, of course. So they just knew
like,
it's raining blood.
Gross.
Yeah, this is a plague. Here come the grasshoppers and crickets next, kind of thing. One of the most common sources of this phenomenon is the Sahara Desert. Winds can lift vast amounts of fine reddish sand high into the atmosphere where it travels across continents. And then when the dust-laden air mixes with the rain-bearing clouds, the result precipitation takes on a reddish hue, creating what is called blood rain. So while the red coloration is most common, similar phenomenon can also produce yellow or brown rain, which would be horrible if it was just
gross.
Like
yellow rain.
Right?
You're like, ugh.
Yeah. Depending on the type of dust or particles present in the atmosphere, that obviously dictates what the color is going to be.
Yeah.
So where and when is blood rain found? Blood rain is most frequently reported in regions downwind of large deserts or areas with fine reddish soil. Some notable causes is southern Europe. It rains blood rain periodically in Spain, Italy, and Greece due to the Saharan dust carried across the Mediterranean by prevailing winds. India, in 2001, the Indian state of Kerala experienced a famous episode of blood rain that lasted for weeks,
Whoa.
drawing worldwide attention and sparking a lot of scientific debate about them. In the United States, it often happens here too. It's often less dramatic, but again, in the American Southwest, because of something like the Haboobs, whenever those collide with raining clouds, and then it falls. I haven't seen blood rain in Texas since I've been here.
Dude, that'd be freaking cool, though.
There's always a chance. Not hoping for it, but so you're saying there's a chance. If I can freaking see a painted bunting one day, I can see blood rain down here, for crying out loud. So blood rain has fascinated scientists and historians alike. While we now understand its connection to airborne dust and sand, earlier theories were far less grounded in science. For centuries, blood rain, like we said earlier, was considered an omen of war, disaster, or divine punishment. Okay, could you just imagine, though? The rain comes, and it doesn't matter what's going on in the world. Somebody is like, it's time for war. You know what I mean? Like, it's just dust that's been picked up, and somebody is like, it's war. Here it is.
You'd be part of the people who are like, it's a call to war, and everybody else is like, we're gonna
die.
We're all, this is it. This is end times.
Yep. So modern research has focused on analyzing the chemical and biological content of blood rain. In many cases, scientists have found that the red coloration comes not just from dust, but also the presence of iron oxide.
I was just going to say, it's got to be the iron. If you've got iron in your soil, for sure, it's going to be making blood rain.
And this is the same compound that gives Mars its red hue.
Or if you've ever seen there's that amazing, I feel like we've talked about it before. In Antarctica, there's that blood falls.
Oh, yeah.
That's
I don't know if we've talked about it before.
If not, we need to.
Yeah, we should. So the blood rain's impact on Earth, while blood rain is fairly rare, its environmental impact can be significant. The dust particles carried in this rain often contain nutrients like phosphorus and nitrogen, which can fertilize soil and boost plant growth. However, these same particles can also carry pollutants or harmful microorganisms, posing risks to water quality and ecosystems. So it's kind of like a double-edged sword. It could do good, but because of the chemicals and everything we have, it can also be pretty bad too. Blood rain has been documented for thousands of years, like we said, often interpreted either as good or bad. For example, in Homer's Iliad, Zeus causes a blood rain as a warning of the slaughter to come on the battlefield, which gives rise to what a lot of people were thinking, we need to go to war, because that story was carried through centuries.
Yeah.
While there's no evidence that blood rain has directly sparked a war, which I thought was interesting, it's often played into existing tensions and fears. Communities might interpret the phenomenon as divine signal to prepare for conflict or confirmation that their worst anxieties about an impending crisis. So
or
it's
that
kind
they're
of
gonna
wherever,
win or whatever. Who knows?
Yeah, it's kind of like whatever your pre-existing thoughts are, you just look at that as a sign of whatever you're already thinking. So if it's like, hey, you know what? I should probably quit my job because this just isn't good. And then all of a sudden start blood raining. I'd be like, I should probably quit what I'm doing. Yeah, right? So blood rain is one of the most interesting phenomenon that reminds us how interconnected our planet is. Dust from the deserts in Africa can travel for thousands of miles. Like I said, it ends up here every year, mixing with rain in other parts of the world to create something that seems interesting, magical. It has a whole lot of stories around it throughout the centuries. Yeah. That's blood rain. And the next one is even weirder than the first two that I talked about. So on that cliffhanger, Laura.
All right. Well, mine is still a biblical plague a little bit, or at least it would seem like it. And I chose to do this last because I also think this is the most sensitive topic, because this one has led to a lot of people dying. And this is firestorms. So wildfires are bad enough. And it's like, LA's still burning. It's a pretty hot topic. But when they're totally massive, they can actually create their own weather. So to form, a firestorm needs, pretty much like any fire, it needs fuel, heat, and wind. The fuel can be any sort of dry vegetation. So these are typically occurring when there has been a drought. Heat from the wildfire can become so hot that it creates strong updrafts. So warm air rises, creates these really strong updrafts.
Yeah.
As the hot air rises, cool air falls rapidly, creating wind, creating these like circular wind patterns.
Terrifying.
Yeah. The hotter the air, the faster the air rises and falls, and the stronger wind it creates. So this is a self-feeding mechanism, just like we talked about before. As the flames are made hotter, or the flames get hotter from the more oxygen they get, and the hotter that they get, the higher the winds go, and the more oxygen they're making. So it's just like going so crazy. So how hot? Firestorms can reach 1,800 degrees Fahrenheit.
Gosh.
That is so hot that it can fracture rock, ignite metal and asphalt, and cause plants to spontaneously combust.
That's insane.
So hot.
So my master's in park and resource management, and Laura and I went to the same grad school, and we did a whole section on within national parks and everything, fighting these things that you're talking about, and then just fires in general, and just how quickly they can. And we're seeing about it so much, unfortunately, in the news in recent years. But just about how terrifying these things are, because it can be so fast, so unpredictable, and so devastating quickly.
And this is where it gets to the point of, okay, you've got a wildfire, and wildfires can be fought. But in these self-feeding systems, this is actually something that you can't do anything about. It has to just burn out. You can't beat something that's 1,800 degrees Fahrenheit. And the winds are so severe, you can't get there with any kind of equipment. Yeah. And metal ignites. What are you going to do? Take in equipment? It just burns.
It ends up coming down to planes dropping. But even then, like you said,
if the wind is too bad, it can't do it.
Yeah.
Yeah. So the winds can reach 100 miles per hour. This is an out-of-control system. It not only fans the flames, but also causes the fires to rush forward at 100 miles per hour, just devouring everything in its path.
Jeez.
And starts smaller fires elsewhere because of those embers are just going all around the place. These wind and flame patterns can cause a fire whirl, which is essentially a fire tornado. So you can just see tornadoes within it.
Are you going to talk about stopping it?
No, I was not going to.
Because I remember we kind of went over some of this. And so they said, like, the only way to really stop it is because of what Laura just said, how it's so hot, it's so crazy. You can't just throw water. So that's whenever they do things like they make fire breaks. They try to contain it and they control it.
Right, get ahead. If you can get far enough ahead, you can do something.
But then again, the winds change, and that's why wildfires are so scary, because those winds can change so quickly. And so you can try as hard as you can to get ahead of it, but you just never know. So it just says, yes, it's using a mixture of water and fire retardant, which again is just more chemicals, PFAS, because I know that's a huge thing that EPA has been focusing on, is PFAS in the waterways. And what a huge one that PFAS is found in is fire retardants. And so it's like a good thing, but at the same time, it's like it's having a really big effect on our waterways and stuff. So yeah, it's just, they said they stop it. It's just coordinating, dampening things ahead of it, so that hopefully everything, by the time it gets there, everything is so wet.
Cut down like a huge swath of trees, so there's
do fire breaks. Yeah.
Nuts. I wanted to talk about, we can imagine what kind of impact that has, but firestorms can be caused both naturally and artificially. And I wanted to talk about two that we've seen some terrible things happen. So of course, I talked in my first section about how those positively charged lightning strikes are like a major culprit of wildfires. That, I'm actually not sure that's how this one started, but the most deadly U.S. forest firestorm was the Peshtigo Fire of 1871 in northeast Wisconsin. It actually happened the same night as the Great Chicago Fire. So it doesn't usually get talked about because that's way more publicized.
Yeah, right? Jeez.
Bad luck. Burning night? What the heck?
Right? Yeah.
So 1.2 to 1.5 million acres burned, and more than 1,200 people died.
How many? 1,200?
1,200.
Jeez.
So it's a lot of people.
Yeah, because back then you
couldn't call your neighbor and say, "Hey, go!"
Yeah,
right? Like this is
no
too late.
Warning. Yeah,
especially if it was a true firestorm where it's rushing and melting every. So that's a forest one, but one that was, and that one people don't know how it started. Was it a lightning strike? Was it somebody who dropped a cigarette? I mean, who knows? But one that was definitely started by us. So the most deadly firestorm ever on record anywhere occurred in Tokyo in 1945. So the U.S. dropped 1,600 tons of incendiary bombs on the city to weaken Japan's war efforts. It's a lot of incendiary bombs. So the bombs dropped. They were super hot. They started creating these updrafts, and then it just, that self-feeding system. And 16 square miles of the city were destroyed, over 250,000 buildings burned, and over 100,000 people died.
How much is that as bomb versus the fire?
Right.
You know
it would be very hard to tell at first. Right. So, but definitely it caused the buildings.
It's not like it made the situation better.
All around it. Firestorms are definitely the most scary one, in my opinion, because it's kind of like a tsunami and there's no getting out of the way.
No, there's just not. Yeah. And that's where it's preventative. So if they tell you to evacuate, we know people don't want to, evacuate their home. I can't imagine trying to make that decision. But at the same time, that's going to end up being your life. A firestorm that can kick up fairly unpredictably. There's, like you said, like there's no way, there's no standing a chance in that. It's going to burn your home. And that means if you hold your ground, that's you too. So you gotta get out of the way. So if they tell you to evacuate, there's typically a reason for that.
And we're just seeing so many more of these firestorms occurring only because of, one, climate change, so more drought in certain areas.
Yep.
Certain areas are just made to burn, like Chaparral. Like, that was bound to happen. But if the debris, the more we prevent wildfires, the more debris builds up. And then when one happens, it's got extra fuel. It's like we dumped fuel onto it. So instead of managing, it then immediately comes out of control. I think that this is going to be, unfortunately, a more and more and more problem, which we even saw here in the Appalachians. In the Smoky Mountains, there was a huge, I mean, that wasn't necessarily a fire. That was not a firestorm. That was just a wildfire, but still. We're seeing them more and more. And let's see here. I graduated college in 11, grad school in 16. And so so 2016, so not quite 10 years ago. And I remember reading that, like I said, reading the chapter on wildfires and being like, you hear about wildfires, but even whenever I was in that class, it was your typical places. Every so often, maybe a couple in California that would make the news. Colorado, you would hear about, but it wasn't where it's constant, and it wasn't where it's all these places. I mean, or impacting so far and wide. I remember like when the Canadian wildfires were happening just a few years ago, we couldn't go outside. Because the smoke in the atmosphere was so bad. Yeah. And that's those were firestorms too. They were out of control. Yeah. And that's what I'm saying. Like it's getting worse. And so for people to look at that and think that, again, global warming, Al Gore was the one that started saying that. And he says to this day that he wishes he never would have made that so popular, because it's climate change. It's changing, and we're definitely not helping it. So if only we lived in a country that could, I don't know, fund a research on science and help us to understand these kind of things, it'd be so much easier. But was that all you had for firestorms? Yeah, so that's firestorms. Terrifying. Just terrifying. Well, I'm going to talk about one that is probably terrifying if you were ancient Egypt, but nowadays... Just freaky. What? Just freaky. Yeah, freaky. It's just like weird. People nowadays would just be like, what? And now that's going to be animal rains. So anything it's raining, whatever. So we've talked about pink snow. We talked about blood rain. But what if the sky opened up and instead of raindrops, fish started falling? Frogs, spiders even? Oh, okay. I'm not even afraid of spiders anymore. But if it was raining spiders, I'd be if it was raining, freaked. Yeah, I'm not afraid of spiders. But if it was raining spiders, hell no. Like, no. No, thank you. So throughout history, reports of creatures suddenly plummeting from the sky have popped up all over the world. So imagine stepping again outside to check the weather, only to be greeted by a downpour of fish. I'd be like, what the heck? I mean, it depends on how fresh they were too, right? Like, how fresh are these fish? I mean, not really fresh, but like the frogs and the spiders would definitely probably hit the ground running. And the spiders would anyway. So the science behind animal rain, it's as bizarre as it sounds. Scientists have studied animal rain, not just to confirm that it happens, but to understand the exact mechanisms behind it. While no one has ever actually witnessed animals being carried up into the sky, which is interesting. So interesting. Yeah, because it's just aliens messing with us, dude. No, right? So people have seen them falling, but nobody has seen them getting sucked up somewhere. Yeah, you'd think with all of our, at this point, weather satellites, you would see water spouts sucking fish up. Like a vacuum. Yeah. I mean,
Well, they can see where it is, but it's not like they can track the fauna being sucked up into it. You know what I mean?
We need little drones all on that. I need to see it.
Right? Yeah, right. So let's just talk about some real life cases, and then I'll go down into what these actually are. So animal rain has been reported across the world, and in some places, it's even fairly often expected. So here's some of the
expected. It's a Tuesday thing, man. Right. It's like, what do you mean expected? Every Tuesday is fish day.
Thursdays we have frogs. Yeah. Fridays is spiders. No,
jeez.
But because it happens so often, it's not. People are here. It comes again.
Everybody just carries an umbrella that can take heavier impact than normal.
Yeah. Is it fish or rain? You gotta just wait till it flops onto the ground to see. So there's fish rain, often documented in Honduras, and they call it the rain of fish, an event that reportedly happens every year in Euro Honduras. Locals claim that after heavy rainstorms, the ground is littered with live fish, for this one is live. So scientists believe that this could be due to water sprouts or strong updrafts, similar to what Laura was saying, from storms pulling fish from nearby rivers and dumping them onto the land. So that one doesn't even have a year because it just happens all the time.
All the time.
So they're pretty used to it.
Dude, live flopping fish, man, can you imagine? You'd be like, sweet. Just going out, collecting fish, especially in a place that just
and if they're alive.
That's what I'm saying.
If they're alive, then it's fresh, yeah. So frog rain in Serbia in 2005, which I don't know. I've never really thought, oh yeah, frogs, Serbia. That makes sense. No, I never would be. Yeah, Serbia is the place they have raining frogs. Amazon, I'd be like, oh yeah, okay, not Serbia. So in 2005, villagers in Ozdaki, Serbia were caught off guard, obviously, when tiny frogs started raining down from the sky.
Thankfully, we're tiny.
Yeah, right. Not just like bullfrogs. Yeah. Pierre, the return of Pierre
No.
Dinom. R.I.P. Pierre Dinom. If you guys have no idea what we're talking about, but go back and listen to the cosmic critters from last week. Yeah. Of talking about, cosmic critters and frogs. Anyway, Pierre and Dinom. In Serbia, though, no one saw a tornado, but meteorologists suspect strong winds scooped them up somehow with a group of amphibians and carried
concentrated enough spot of frogs to even do
apparently,
that. There's
and so
some excellent, awesome frog bog in Serbia somewhere.
Right? In Serbia, apparently, yeah. And it carried them over the town before dropping them. Just nature confetti, I guess. Spider rain, of course, in Australia. Where else would
it is?
Right? Australia. So that was 2015. So if Australia wasn't already home to enough nightmare fuel and I love Australia, but in 2015, parts of New South Wales experienced a rain of tiny spiders. This phenomenon, known as ballooning, happens when spiders use silk to catch the wind and travel long distances. Normally, it's an isolated event, but sometimes thousands of them decide to take flight at once.
I've seen pictures
creating
of
a horrifying illusion that it's raining spiders. So this one isn't necessarily that they're like
precipitating. Yeah.
But it looks like it because they're catching wind to travel long distances, and when thousands upon thousands of them do them all at the same time, they do get pretty high, and then they start dropping. No, thank you. Then another interesting one happened in 2015. I don't know what happened in 2015 because that's when Australia had this crazy spider rain. In Norway, worm rain.
Whoa.
Yeah.
That's crazy.
In 2015, a biology teacher in Norway reported finding worms scattered all over the snow-covered ground. At first, he thought they had crawled up from the earth, but nope, these worms appeared to have fallen from the sky. And then other people started coming forward being like, did you see? And it was raining worms. Strong winds are the likely culprit, but again, and they're thinking that lifting the worms up and carrying them before dropping them where people are.
Fudge.
Right? So the physics of animal rain. All right. Now that we've seen kind of how the different events have taken place, let's break down a little bit of the science behind it, or rather the physics, I should say, behind how it happens. So meteorologists have long suspected that water spouts and strong updrafts are responsible for these strange events, but researchers have taken it a step further by analyzing wind speeds and storm patterns where animal rains have occurred. One study published in the Journal of Meteorology examined water spouts in regions where fish rain had frequently reported, confirming that these storms are definitely powerful enough to lift any small aquatic animals into the air. Dr. Ernst Agee, right? and atmospheric scientists at Purdue University calculated that a strong water spout could lift objects as heavy as 4 pounds, which would be the size of a small fish or a frog, or even a small chihuahua if you got lucky, and carry them for miles before they fell back onto the ground. Other studies on tornadoes have shown that debris, like building materials, even vehicles, can be carried dozens of miles. So that's not too much of a stretch to think the same concept could happen with frogs and fish and things. So analyzing the animals themselves, though, is some researchers have taken a more hands-on approach by analyzing the animals that do fall from the sky.
Yeah.
In cases of fish rain, scientists have collected specimens to determine whether they were species found in nearby bodies of water or they transported from farther away. In multiple cases, the fish have been discovered still alive, meaning that they weren't dropped from too high or too far. Just really tough fish. In 2017, the biologists studying the events in Honduras took samples of the fish that rained down in Euro. Their analysis found that the fish were freshwater species, but oddly, they weren't from any nearby rivers.
Whoa.
This suggests that they might have been pulled from underground water sources, raising even more questions about how the heck they got there in the first place.
Trolling aliens.
Right? Yeah, they're just like, this will mess with them. And again, so that was 2015 was the first one I talked about in Honduras. So in 2017 is whenever they were like, maybe these are, because they were found from like an underground water source. So we've talked a few different times about aquifers fish that you found down in aquifers, which is crazy. For the cases of frogs and spider rain, scientists have also looked at whether mass migration events could play a role. And in some instances, large groups of amphibians may already have been moving across an area when southern weather events just sucked them up, displaced them, whatever. This means that some reports of animal rain, quote unquote, might just be a really bad timing case instead of just rain. So heavy rains causing flood of creatures at the exact moment people happen to just look outside kind of thing.
Oh, right. So they're not falling from the sky, but they're there. Like,
they're there. And so people are like, how the heck else could they? They must have fallen from the sky kind of thing.
Gotcha.
Animal rain has definitely been reported for centuries, and historical records show that people have always just been baffled by it. The Roman naturalist Pliny the Elder, which also hilarious name, Pliny the Elder, wrote about storms that showered fish in ancient Greece and the 19th century France, where multiple reports of frog rains were witnessed by entire towns. One of the earliest recorded studies on animal rains was conducted by 19th century French naturalist André-Marie Ampère, who suggested that strong winds were lifting animals from their habitats and carrying them from long distances before just depositing them elsewhere. His theory was met with skepticism at the time because, like, back then, 19th century, nobody's going to believe him. But modern meteorology has largely confirmed his suspicion. In 1919, the Scientific American article detailed a case in Shreveport, Louisiana, where hundreds of fish fell from the sky during a rainstorm. Witnesses described the fish as perfectly fresh, some even still flopping around. So again, it's just been throughout history that this has happened, whether it's actual rain or not.
Yeah.
We definitely still don't have all of the answers, like where are all these fish coming from in Honduras or something. But one thing's for sure, if it starts raining frogs outside, it's not a plague. We're not in ancient Egypt. We can use science to figure out what this is. It's just going to take a little bit more of a understanding in some time. So that's animal rain.
Wow. I do have nature news. I remembered I read this, which totally ties into this entire week. Okay, so here is some, it's not like new nature news. This actually happened like 150 years ago, but it's the anniversary of the event. Okay.
Laura, let's refresh what news mean. No, go ahead.
I'm just really late to the party. No, it's the anniversary of it. So
okay.
Let us remember the anniversary of the Great Kentucky Meat Shower.
Oh,
which first of all is such a great name for something. The Great Kentucky Meat Shower that happened in 1876. So in Kentucky in 1876, there was a woman, I'm reading this from an article. This one I'm getting from WATE6, but there's a whole bunch of articles on this. There was a lady outside making soap when all of a sudden large chunks of flesh fell from the sky. Yeah, just a literal meat shower.
I get fish, frogs, animal wise, I'd be like, but at the same time, just like
chunks of meat. Yeah, I'd be freaking out, dude. Everyone was like, no idea, and it wasn't even just this lady you saw. Neighbors saw it too. The owner woman's husband said the meat fell like large snowflakes, which also makes it seem like it's not plopping, but
I looked outside and saw gently falling flat chunks of meat.
So a whole bunch of people came out to investigate. One person made note of the meat sticking out of fences and scattered across the ground.
Ugh.
Most of them were about 5 by 5 centimeters, but one was 10 square centimeters, which is a giant chunk of meat.
Yeah.
And it seemed pretty fresh. So, two other men who remained unidentified turned up and taste tested the meat rain.
Of course.
Of course they did. Which they were like, this is either venison or mutton. So either deer or sheep is what they said. But some doctor took it back.
Leave it to a dude. All I'm going to say, leave it to a dude to taste it.
One doctor took it back and analyzed it. And he's like, this is lung tissue from either from a horse or an infant. Which is he just escalated that. It's either lung tissue from a horse.
This is either cow or
baby.
Yeah, this guy's looking at. No. I think it's horse or the blood of our infants. Like, jeez.
Some person, it says a man analyzed some of the preserved.
Also, wait, hold on, pause. You imagine how many baby lungs that would have to be?
That's what I'm saying. That's a lot of baby lungs.
So many baby lungs.
Somebody who analyzed some of the preserved meat specimens said it might not be actually meat, but it's like gelatinous bacteria called witch's butter, which I have actually heard of.
Okay.
And star slubber.
All great names. Yeah. All such great, horrible names.
Okay, it says pair of histologists later analyzed 7 of the specimens and found 2 to be lung tissue, 2 were made of cartilage, and 3 were more muscular tissue. Somebody was like, this is just vulture vomit.
Ew, yeah.
But that's a lot of puke, I guess, depending on how many pieces there were.
But also still better than baby lungs. Yeah. I mean...
Somebody else, he set fire to it and it smelled like sheep mutton. Disgorgement of some vultures that were sailing over the spot, like multiple vultures just barfing. Whoa, just everywhere.
They just, can you imagine? Hey guys, this is the spot. Okay, ready? Just all at once.
They're like, this is the only explanation because it's such a variety of tissues. My immediate thought though was like some tornado just blended an animal. You never know. Yes. Those crazy winds can do stuff. So, I mean, it's still kind of unknown. But
did they debunk the baby meat though?
I don't know. There actually is still some you can actually see it. There's like a museum of this phenomenon in Kentucky, and you can go and see some of the preserved meat in a little glass bottle. So yeah, let us never forget the 1876 Kentucky meat shower.
Baby chunks of babies. Ew. Oh goodness. All right guys, well make sure you go check us out on Patreon and YouTube. I've been uploading the videos, so if you want to see Laura and our faces as we do these episodes. We've been uploading them onto YouTube. If you go support us on Patreon, that definitely helps us to pay for all the stuff to be able to help bring this to you guys week after week. So we definitely appreciate anybody who can help us out there. And I upload like a lot of shorts and everything onto YouTube too, which are pretty fun to watch as well.
Taking us out of context is pretty amazing.
Yeah, them out of context, I feel like it's funny when I'm going through and editing and stuff. It's funny, but then out of context to me, it's like, way funnier. Way funnier. Yeah. So, like I said, go check us out on YouTube and Patreon. Until next week, we'll talk to you guys then. Time.